Okay, so this is the last notes for 2020 Honors Math 2. I may add more videos to review something, but this is the last lesson that we are completing. And so basically it's just a review of everything you've done actually in Unit 12 and Unit 13. It's solving by different methods. So you've learned a lot of different ways to solve quadratics. And a quadratic could look like this. And a quadratic is anything that has an x squared. But it also can look like this. Okay? Or it could look like this, where you don't have a c value. And the first thing we did was we did square rooting, and that was in chapter Unit 12. And that was when you had no b value. So for example, x squared, or 3x squared minus 32 equals 0, something like that. That's not a good example, but maybe 28. Okay, so you had no b value. You could move the 28, divide by 3, square root. Factoring, you want to do this anytime you see it's easy to factor. So like an easy to factor question would be something like x squared plus 7x plus 10, when you know the two values are 5 and 2. Why do a different method when you can factor? Completing the square is good to use if b is even and a is 1. You could do it other things, but that's a good one if b is even and a is 1. So something like x squared plus 4x minus 10 equals 0. You might want to do completing the square because that's not factorable. Quadratic formula anytime. So even if the problem was factorable and you should have factored, you can do the quadratic formula and get the same answer. Even if it doesn't have a b value, you can use the quadratic formula. Even if you could have completed the square, anytime. Works all the time. So it's a safe way to say, oh, I don't know how to do the problem. I'm too lazy to factor. I'm too lazy to guess and check. And most of the time people will use the quadratic formula if a is a number other than 1, 2. Okay, so we're going to go through some equations and we're going to figure out what method should we use. And you can use any method, and actually one of the questions on the homework will ask you to use all 3 methods to see which one you think would be the best, just so you look at it. So I'm looking at this equation. I could try to factor that. I'm thinking it probably doesn't factor and I don't want to waste my time. So I'm going to do the quadratic formula. Because even if I tried to factor it and it didn't factor, I wasted a lot of time, just use the quadratic formula. So negative b plus or minus b squared minus 4 times a times c all over 2 times a. Yes, quadratic formula is a pain and sometimes takes a long time, but it's safe to use anytime. So we have 169 plus 20 over 10. And this is 189 inside there. And remember the trick, if it's divisible by 9, they add up to be a multiple of 9. That adds up to 18, so I know it's divisible by 9. It goes in 21 times, and 9 is 3 times 3. 21 is not going to break down much, so we're going to have negative 13 plus or minus 3 radical 21 over 10. This can't be reduced by any number, so we're done. All 3 of them have to be reduced by the same number. Not the square root, but all those. So quadratic formula worked. We're done. We have 2 answers, plus or minus. This one, I'm looking at it and I said, I could do the quadratic formula if I make it equal 0. I can just, it's kind of set up for square root, so I could divide both sides of 169. Why would I do square rooting? Because there's no b value. And so I have x squared equals 36 over 169, and then I look at this and I say, oh, those are both perfect squares. Square root of 36 is 6, and square root of 69 is 13. So I get equals plus or minus. Remember, you always get 2 answers, plus or minus. So I use square roots to solve that one. Okay, so now we're going to go to the bottom 2. I look at this question, and I'm like, 60, easy, 6 times 10. So I would factor this, because then I go 10 minus 6 is 4, so I could factor this. X plus 10. X minus 6, 10 minus 6 is 4, 10 times negative 6 is negative 60, and solve, I get x equals negative 10 and x equals 6. I could have also completed the square, but I decided to factor. Okay, you can complete the square also on that one and get the same answer. And I don't know why I threw another square rooting one, but another one, people forgot to do it. No b value, I'm going to add 15 to both sides and just solve by square rooting. 15 doesn't break down, so you must have plus or minus radical 15. And remember, if this is a negative, you'd have an I there. So, just different times. A lot of people do like to do completing the square. I didn't show you one, but you could also do completing the square. So let's show you completing the square on the bottom, on the back. Okay, so if I'm looking at the next one, I'm thinking to myself, whoops, the wind's blowing my paper. I'm thinking to myself, not factorable, 6 and 2, 4 and 3. So this is a good one to complete the square. Why? B is even. Remember when you complete the square, so this is a good little review of things. You move the 12 to the other side by subtracting 12. I like to put a number here. And you put a square. Take half that number, and you square it. That's 25. Whatever you do to one side of the equation, you have to do the other. And that gives you 13. And most of you guys' mistakes are because of the sign here. And then you solve. Now you're not going to move the 13 back over and find the vertex. You're going to solve by square rooting. So you get x minus 5 equals plus or minus radical 13, and then you add 5 to both sides. So your answer would be 5 plus or minus, whoops, I forgot the radical 13. If we would have done the quadratic format, we would have got that same answer, and what would have happened is we would have reduced all by 2, and we would have got that answer. So you should be able to look at the problem and say, I could have done any way and got the same answer. Okay, this one, I'm going to factor. Why? Well, I look at the b value and it's 1. I don't want to take half of an odd number. And I look at 6 times 5. And remember, when you solve, it's the opposite. But if you decided to do the quadratic formula, you get the same answer. Okay, so review. I reviewed completing the square, I reviewed factoring, square rooting, and quadratic formula. Now we're just going to do a little reviewing of graphing, so you guys get an idea. And so I have one graph in vertex form, one graph in standard form, and one graph in factored form. And so you remember how to do each question. So like I said, this is like the end where you remember everything. This is a vertex form. Remember, this -3 is going to make it upside down. It's also going to make it look skinnier. The vertex is the opposite, so 2, and this 12. Okay, now these are going to go off my graph a little bit. So what I'm going to do is I'm going to number these 2, 4, by 8, 10, 12. I'm going to do them by 2s. I'm going to do these by 1s. So 2, 12 is up here. Again, I know it's going to open down. Line of symmetry is x equals 2. So every dot I get is going to go on either side. X-intercepts. Okay, to remember to find the x-intercept, you let y equal 0. Let's do the y-intercept first. To find the y-intercept, you let x equal 0. That's -2 squared is 4. And so you get 4 times -3 is -12, plus 12, which is 0. So our y-intercept is at 0, 0. Now I'm going to use my line of symmetry, and I haven't talked about this a lot, to put this point. And from now, I could graph it. I also now know the x-intercept. But let's also do it. To find the x-intercept, you let the equation equal 0, and you solve by square rooting in this case. So we're going to subtract 12 from both sides. -12 equals -3 x minus 2 squared. Divide by -3. 4 equals x minus 2 squared. And most of the time these will come out to be whole numbers. I gave you one on, I think, 13.2 that came out to be a square root, but most of the time they're going to come out to be whole numbers. This is plus or minus 2. And then we're going to add 2 to both sides. So we get 2 plus 2, which is 4, 0. And we get -2 + 2, which is 0, 0, which I already kind of figured out. Okay, so that's how you solve it if it's in vertex form. Gives you the vertex, gives you the line of symmetry. Sometimes you could use that line of symmetry to help you find other things. Okay, now this one is in standard form. Good thing about standard form is I know the y-intercept is 0, -5. Okay? I know that. Oh, I think I'm going to have to number these by 2. Okay, we'll go back to that. I am going to factor this. X minus 5, x plus 1. Make it equal 0 to find the x-intercept, so x equals 5 and -1, 0. So let's go 1, 2, 3, 4, 5, and -1, 0. And so that means our line of symmetry would be 1, 2, 3, 1, 2, 3. Line of symmetry, or axis of symmetry would be at x equals 2. And now you have a couple choices. You can do completing the square to find vertex form, or you can plug in 2 and find the vertex. I'm going to complete the square, just remind you guys how to do that. Whenever you put a square, put the 5 over here. Half of 4 squared is 2, 2 squared is 4. So you get x minus 2 squared equals 9, and then you move the 9 over. And you get x minus 2 squared minus 9 is your equation. So your vertex is 2, -9. So let me go back. I need to number these by 2. So -2, -4, -6, -8, -9. So 2, -9 is going to be here, and then that x-intercept of -5 is going to be there. And again, I can use the line of symmetry to kind of help me. So there's your graph. You can, anytime you want to label things by 2, especially on the y-axis, you guys can. I could have also, going back, plugged the 2 in here and got 4 minus 8 minus 5. That's -4 minus 5, which is -9, and got my vertex that way. Up to you guys. Okay, last one. Woo. Okay, so this is in vertex form. Factored form. I know the 1/4 is going to make it a very wide graph. I know that I'm going to have an x-intercept of -3, 0, and 3, 0. So I might as well put those on. What does that mean my axis symmetry is? At 0. Okay, so to find the y-intercept, you let x equal 0. So you're going to go 1/4, 0 plus 3, which is 3, 0 minus 3, which is -3, and you're going to get a fraction, -9/4. So your y-intercept is 0, -9/4. Well, that's about -2 1/4, yeah, so -2 1/4 right about here. And I could graph everything. Well, I actually can graph everything. I kind of noticed that that's in the middle, so I kind of know that would be my vertex. But if you weren't sure, you could find the vertex by plugging 0 in here, which is the same thing we did there, so why do it again? And you have your graph. Again, the -3 made it upside down and skinny. This is normal. This is wide. These two open up because A is positive. That one because it's negative. So this reviews everything in the last 2 chapters. Okay, hopefully if you have any questions, please let me know, and good luck.